Welcome everybody. Today we will be talking about OSI model, which is chapter number 7 of our networking course. So mainly we are going to discuss two main things. Firstly, I'll give you a detailed description of OSI model, the working of OSI model. We will discuss that. And mainly we will discuss why OSI model was proposed. What exactly the problem it is trying to resolve. What was the problem? Why OSI model was proposed? We'll talk about it. Then in the second agenda item, we'll discuss few protocols, DHCP, DNS, RIP, and several other protocols. I'll give you just an overview of these protocols. So firstly, let's start with OSI model, what OSI model is. So OSI stands for Open System Interconnection. And this particular model was proposed by ISO, International Organization of Standardization, and they proposed this model in 1976. This model was proposed in 1976, but implemented, like the guidance, it's a reference model. I'm going to give you an explanation about it, but it was implemented in 1986 in the form of TCP/IP protocol. So the TCP/IP protocol is basically the practical form of OSI model. The practical shape of OSI model was converted into TCP/IP model, the one which we use. Now, what is OSI model? This is how it looks like, the 7 layers. For example, two computers, let's say I have a computer 1 and this is my computer 2. They want to communicate with each other. So I have two computers and I want them to communicate with each other, how they can talk to each other. So there should be some sort of protocols, like they should follow some set of rules or something like that, and then they can communicate. What if I tell you over internet, just imagine over internet, how complex the situation is. Over internet, we have different devices, different architectures, different computers plus different sort of architectures. So we got different computers, different architectures. So they are designed in differently. They might have different, for example, communication protocol, communication model. How we can let them communicate? How they can communicate with each other if they are using a different architecture, computing model. In order to solve this particular problem where we have different computers, different architecture, ISO, they came up with a model called OSI model. And this reference model, it basically, they provide us some guidance. They provide us guidance, reference, like, or you can say steps, how computers, they can communicate with each other, how they can talk to each other by following a certain mechanism, how they can talk to each other. And this is basically the reference model they came up with, like a 7 layers architecture. One thing which is very important to understand, because people, they do confuse OSI with software and things like that. So first of all, OSI model, it is not a software. It's not a software. What does it mean? It means like you cannot install it. Like it's not basically a software. It cannot be installed. Second thing, it is not basically a protocol. OSI model is not a protocol. It does have protocol inside it, but it's not a protocol. Let me give you a basic understanding. What is the difference between OSI and TCP/IP protocol? Because people, they do confuse OSI with TCP/IP. So let's discuss this and address this problem once for all. For example, let's say you want to build a house. Let's say this is a house. You want to build this house, for example. You want to build a house. Okay. So if you want to build a house, there is certain protocols, like there are some steps. If you want to build this house, you need to, for example, first of all, make a layout. Okay. First of all, the drawing of the house, maybe. After that, let's say you are going to, for example, build foundation. You are going to build foundation. After you got the foundation, then you will make a structure. Okay, over that. Then you can actually put the walls, for example, the dry walls and all that. After you got it, then you need to, for example, do paint. Then you need to install, for example, flooring, for example. Then you need to install, for example, appliances and all that, right? So all these are basically the steps. So what are the steps? First step is this is basically you're trying to achieve. You can, for example, you have to have a layout. Then you need to build a foundation, structure, walls, etc., etc. All these are different steps, right? So now the thing is, exactly the same way this OSI model is basically based on. OSI model basically give you a reference model like what you need to do in order to let two computers to communicate. So if you want two computers to communicate, you want a computer one to send a message to computer two, these are the guidance. Like they divided the guidance of the steps in different steps, different layers. Got it? And what is TCP/IP now? Let's try to understand what is TCP/IP as compared to OSI. So it tells you, like for example, right here, let's say they ask you, okay, you need to do paint, but they didn't tell you which paint you can do, right? For example, you are installing flooring, you need to install a floor, but did they tell you you need to, for example, the specific is you can only install, for example, the wooden floor, you cannot put the tiles. Are you getting the point? Which color paint? Did they tell you you need to always do the blue paint inside walls and all that? No. Are you getting the point? So TCP/IP protocol is basically what we have customized it. The OSI model, we have customized it with came up with our idea. Like we're gonna use this protocol, we're gonna use this. I believe it give you a good understanding about now what exactly the OSI model and TCP/IP. So OSI model is basically a reference model. It is a reference model, while TCP/IP protocol is the one which is the practical one, the one which we have implemented. That's the major difference. Got it? So one definition which I would like to share here for OSI model, I just want to actually put it down here so we can understand it. Let me just clean this. So if you want to define OSI, then OSI model, what a OSI model does, it allows two or more computers to communicate regardless of their architectures. So their architectures could be different, but by using OSI model, we got a standardized a benchmark which we need to achieve. OSI model is basically divided into 7 layers. We will discuss all these layers, which devices work, etc., etc. We'll talk about it. But what happens here? Let's say this is basically the data which you want to transmit. So you have a data which you want to transmit. When this data will get to the application layer, so application layer is going to add its own header, application header, and that particular header will based on having some protocols, some things like that. We will talk about it in a bit. When this particular thing or this packet or segment, whatever you want to name it, get to the next layer, then it will add another header. So now it will have a data. It will have, for example, data having the application header. And now when it get to the next layer, it got to the presentation layer. Presentation layer will add its own header, PH. Then when this particular segment will go to the next layer, same thing, everything else is going to be same. We will have the same data, authentication header, which was carrying forward, presentation header, session layer will add its own header. When this particular packet, like this one, will get to the transport layer, same thing, we got the data, we have previous authentication, the application header, presentation header, session header, and then transport header would be added, okay? And then when it get to the network layer, network header would be added. When it will get to the data link layer, here we will add the data link header as well, okay? And then finally, when this particular thing will get to all these things would be right here, okay? Please remember, everything else would be exactly the same. When it get to the last layer, which is physical layer, it will be converted into bits, and then finally signals, and it can leave your computer. So this is just a reference model or overview of the OSI model. I hope everybody understood what OSI model is. OSI model allows two computers, they can have different architecture and how they can communicate. A reference model. The practical model that we use is the TCP/IP model. Okay, please do bring the questions if you guys will have any questions. Okay. So let's understand the OSI model with this perspective, with this example. And let's say if I make it, this is sender side. And for example, this is my receiver side. Now, by using this example, I think it will make more sense to you to understand it. You may have a question, for example, which is the first layer? So typically we take Physical layer is considered as the first layer, 1, 2, 3, 4, 5, 6, 7. But you know what? Honestly speaking, it is basically the perspective. For example, if you are sitting at the sender side, your sender, application layer is going to be your first point of contact. And when you are receiving the data, you would be, for example, the physical layer is going to be your first point of contact. But typically we take this particular sequence. Okay. Now, to better understand this, concept, like the layering concept, I will tell you the technical part. But let me just narrate a small story. Let me just tell you a story and try to explain to you how exactly it works. Okay, the mechanism. Now, for example, let's say application layer is, let's say this is our CEO. Application layer person name is Andy. Let's say you have a small company. You have a company and having 7 employees. And your company is, for example, you guys are, let's say your company is a German company. It's a German company, but New York based, for example. It's a New York based German company. And let's say this is also American. This is an American company. The receiver is American company. Company name is XYZ. And this company is located in Texas, for example. Okay. Now, your CEO, this is your CEO, Andy, and he is, for example, a French person or German guy. He's a German person. Now we have, for example, another employee under CEO. Let's say the name of this employee is Pam. So, and let's say session layer, let's make it Sam. Then we have transport layer, let's say Tom. This is, for example, Natty. And the data link layer, let's name it, for example, Dave. And let's say physical is Pat. So for example, we have a small company having these 7 employees. We have Andy as a CEO, who's a German person, only understands German language. Then we got Pam. Then we have Sam, Tom, Natty, Dave, Pat. Okay, these people. Let's say how they communicate, how exactly what the communication is going to happen. So for example, Andy, CEO. Andy, CEO, wrote a 400 pages report, and Andy wants to send this particular report to XYZ company. So we got a report, 400 pages report. This is 400 pages report. Andy wrote a report and want to send this particular report to the CEO of XYZ company, which is a Texas-based American company, only understand English language. So they only understand English language, right? American English. But Andy is a German guy. He only understands German. So Andy wrote a report, and this report is in German language. And Andy asked Pam, hey, can you please forward this report to XYZ company CEO? Pam got it. Pam got it. Okay, thank you, sir. Pam got it. Pam saw this report is written in a German language. But Pam knows that XYZ company CEO, he is American and he can only understand English language. So what Pam did? Pam converted German language into English. Like all these 400 pages are converted into English so receiver can understand it. Got it? So he saw all the pages were in German, so he converted into English language. And then he forwarded it to Sam. So Pam, after converting it, forwarded it to Sam. Now, and I told him, Sam, this is very, very important. We need to send it to XYZ company. Got it? So what Sam did? Sam made a call. Sam made a call to his counterpart. So Sam called him. Sam made a call him. Called the counterpart in XYZ company and tell him, hey, you know what? We are going to send you a letter or a document having 400 pages. Can you tell me for how long you guys will be open? So let's say this guy responded, we will be open until 8, for example. Sam said, okay, no problem. What I'm going to do is we are going to send you a 400 pages report. Whenever you receive it, just give me a call back. Got it? No. After that, he said, okay, whenever I receive it, I'll send you acknowledgement. Okay. But right now, acknowledgement is, because they didn't receive it. So whenever they will get it, they will respond back to Sam. Okay. Sam is basically, he's right now following up with everybody. And for example, unless Sam is gonna vigilant, unless the report will get to the other person once they receive acknowledgement from them. After that, what Sam did, Sam forwarded that report to Tom and tell him, Tom, this is 400 pages. these are the 400 pages, send these 400 pages to, for example, this company, and I'm with them over the phone. What Tom did, Tom saw 400 pages and Tom is very scared. Tom said, okay, 400 pages and very critical. So Tom got an idea and Tom divided these 400 pages report into four pages, not 4 pages, into 4 parts. This is, for example, frame 1, frame 2, frame 3, frame 4, not frame, packet. Each particular packet has 100 pages. So Tom made bundle of 100 bundle and just put the names. So for example, let's say bundle number 1 is lost. Still, the receiver will get 300 pages or 300, for example, 300 pages or 3 bundles, you can say. So that's basically Tom's idea. Now Tom forward these 4 pages, or you can say 4 bundles having 400 pages to Nettie. She works on a network layer. What Nettie did, when Nettie got it, Nettie basically, and again Tom told Nettie like, hey, we need to send it to, for example, the Texas company. So what Nettie did, Nettie, she basically wrote to and from on each particular packet, like from where the packet is coming to, and from, to, and from, to, and from. So Nettie just wrote it to and from, and after writing it down, Nettie forward this to Dave and told Dave, hey, Dave, we need to send it as soon as possible to the other company. No, and also Nettie forward a route as well, like which route is going to be a feasible route for your driver. So Dave got it. Dave got this, and Dave know the route as well. But when Dave is about to forward to physical layer, or you can say Pat, what Dave saw, I mean, these are not basically sealed envelope. Like anybody can, for example, do the modifications. So what he did, he basically sealed all envelopes. So all the envelope 1, 2, 3 are now sealed. If anybody, for example, tamper it, it can be detected. So any sort of tampering would be detected. And then he handed over to Pat, who's, for example, your company's driver. And what he did, he basically followed the route provided by Nettie to Dave and forward these sealed envelope to Dave, to the XYZ company. Now, once XYZ company got it, they got this. After they got it, what they're going to do is they are going to forward it to data link layer, which is, again, they might have their own person working on this layer. He will basically verify the seal like no tampering. If there is no tampering, then what it's going to do is forward it to network guy, like sitting on this particular layer. They will basically check it out, verify the address, okay, we got it. And then it will forward to transport layer guy. Transport layer person will get these four bundles, and he will combine them all, combine back into 400 pages. And once it will be combined into 400 pages, it will forward to this guy, session layer. Session layer person is your communication person. He will make a call to Sam and told him, hey, Sam, we got it. We got your 400 pages. Sam will say, okay, thank you very much. And now Sam will cut the call. So call will be disconnected. Now it's not the Sam's headache whether CEO reads it or not. Then after that, it would be given to presentation layer. If there would be any kind of coding, secret code or something, it would be decrypted. And then finally, CEO is going to write it. This is basically the whole story, the communication. You guys, I mean, please watch this video again if you will have any other question. It's a very interesting story, by the way. Now, I'm going to actually tell you, practically speaking, I'm going to explain you step by step what happens at application layer, which devices run on application layer and all that. So all these layer, application, presentation, session layer, typically we call these layers as a software layers because mostly the software work on these layer. The transport layer is a very important layer. It acts as a heart between software layers and the last hardware layers. It allows them to coordinate. These are called hardware layers. Okay. So I hope you guys got the story. You understood the story, what's happening here. And now let's talk about the technical aspects about it. Okay. Let's technically understand it, the OSI model now. So if you see here, firstly, we have the application layer. On application layer, it's the first point of contact. First point of contact, and all the software run on this particular layer. So software run on this layer, for example, your browser, for example, the browser, for example, the GUI based applications. GUI based applications, it allows users to interact. Okay, so browser is the first point of contact in our case if we try to understand it with our perspective. And which sort of protocols runs on this layer, protocols which run on this particular layer, whatever you can do with your browser, whatever typically you can do with your browser or over internet runs on that. For example, let's say protocols are like FTP protocol runs on it, file transfer protocol, we will discuss it in detail, HTTP hypertext transfer protocol, hypertext transfer protocol secure, HTTPS, POP3 like the email post office protocol 3, we'll talk about it. SMTP, simple mail transfer protocol works on it. IMAP, internet message application protocol, we'll discuss that. Internet message access protocol, we'll discuss that. Telnet protocol, similarly DNS protocol, domain name system, DHCP protocol, etc. There are many other like SNMP or some other protocols as well. They also work on this layer. Which sort of devices run on the application layer? Devices, if you talk about hardware one, it's just the computer. But mainly it's basically the software layer. Okay, it includes all the software mainly on this particular layer. Next, we got application layer, presentation layer. Sorry about that. So after the, let's say you have created a packet. Let's say you got a packet. Let's say you have created a data, and on the data you just, for example, if you're downloading something. Now, how this data would be presented? It's gonna be basically the task of the presentation layer. So on presentation layer, what typically we do? On presentation layer, we encrypt the data. So it performs encryption. It performs decryption. For example, you got a encrypted data, how it would be decrypted like receiver. So sender encrypted decryption will be performed by the destination or receiver. Then we will also data compression or, for example, decompression. So all these activities are being performed at the presentation layer. There is no device. So devices, no device applicable on the presentation layer. It's again totally software based. It's another way to understand it. For example, let's say if we have a file abc dot, for example, docx, or for example, abc. Let's say if I ask you how we can open this file. So if you double click this file, this particular file will open with Microsoft Word, right? So we need a Microsoft Word. Who told us the filing system? It's basically the presentation layer. It tells how it's going to open. And for example, if I have a file ABC with no extension, how do we know that how this file is going to open? We don't know. We need to right click it and then we will find out the right software to open it up. So presentation layer tells how the data will be presented. How the data will be presented. Okay, encryption, decryption, and all that kind of things. Again, on the TCP IP layer, we'll talk about it more specifically. Then we got a session layer. Remember the person who calls SAM. This is what the job of the SAM. So what exactly it does? It basically responsible for log on, like login, log off, for example, logins, log off. There is a protocol called NetBIOS. Okay, network basic input output, plus the negotiation with the receiver. All that stuff is being performed here. It's basically devices. If you talk about any devices, not applicable. It's again a software based layer. And it also provides the logical ports as well. The logical ports for each particular protocol. Like FTP, which port it's going to use. All these ports will be basically assigned at session layer. Then we got a transport layer. We have already talked about transport layer. On transport layer, there are mainly two type of protocols actually run. So whenever we send a packet over internet, a packet can be a TCP packet or it can be a UDP packet. So packet can be TCP, packet can be UDP. UDP is basically connectionless, unreliable. TCP is slow but reliable. We'll talk about it. I'll give you definition about all these. Let's say if you're watching a YouTube video. Okay, you're watching a YouTube video, you're going to transmit TCP packets. If you, for example, send a ping packet to someone, You don't know whether it's going to be received or not. It's basically a UDP packet. Got it? Broadcasting is typically the UDP. So what we do on the transport layer, we typically perform segmentation. Remember the 400 pages, we converted those 400 pages into 4 chunks, 100 chunks. Okay, device, not applicable. It's basically just a software based defined one. Next is basically our network layer. Network layer is the one where, if you talk about the protocols which runs on the network layer. So network layer is basically responsible for IP protocol, like assigning IP addresses and all that. ICMP, Internet Control Messaging Protocol. This is basically ping and trace out. Okay, ping ICMP protocol run on this. ARP protocol, Address Resolution Protocol. I'm going to give you a definition of that as well. RIP, this is Routing Information Protocol. IPX, these protocol run on the network layer. Okay, and now if you ask about the devices, routers plus the layer 3 switches. Layer 3 switches runs on this particular. It's basically over layer number 3. This is 1, 2, 3 and all. Then the data link layer. Data link layer is responsible for Ethernet, MAC addresses, MAC frames. It basically design or construct the frames. Remember frames that we have the MAC address of source plus destination? That's what it does. It also performs a CRC, cyclic redundancy check. You can say error correction plus detection. Remember the seal we talked about here? Remember? It basically do the seal. Like for example, any tampering and all that stuff is basically performed here. Devices, if you ask about the data link devices, we have already discussed network interface cards. We have discussed switches. We have discussed the bridges. And the wireless access points, WAP, wireless access points. They also run on this particular layer. Last but not the least is basically the physical layer. Physical layer include the cables, the wires, like 100 base T, for example, the cable. Remember the 100 Mbps up to 100 meters, 1000 base T. And what exactly this particular layer does, it converts the data into bits. And then finally signaling, responsible for signaling, like transmitting of the data, in fact. And if you ask the devices, devices are, we got repeaters. We have repeaters. We have hubs runs on it, RJ45 connector, and these kind of things are basically operate connectors. So this is basically like a complete detail about OSI model, what each layer does and what sort of protocols are basically performed here. You guys can see here when user open up computer, user will interact with web application. Got it? So web application, or you can say the web browser, for example. So web browser, then for example, if you have created a data, after that data, how the data would be presented, like encryption, decryption and all that, then it will basically make a session like login, call the other party, we are going to send the data, and then it will basically break down the data here into different parts. So you can say what's going to happen at transport layer, we will have the segment ready, like segment packet number 1. Then when it get to the network layer, it will convert the data into packets, like where it will add source plus destination IP addresses. Got it? Then when it get to the data link layer, this packet will turn into frames where we will add source plus destination MAC addresses, and lastly it will become into bits, then it will be forwarded. So this is basically what happens when you do a communication from application layer to physical layer. So I hope you guys understood. These are explanation, and this is basically practically what happens. Your data encrypted, session like login, make a call to receiver, and then segmentation, packaging, where we will add the source and destination IP addresses, source and destination MAC addresses, convert it into bits, and then we will transmit it. Now just a quick definition of TCP versus UDP and some other protocols. So TCP, as I mentioned earlier, packets, or you can say your frames. Frames can be either TCP or frame can be UDP. Okay, so what is TCP? TCP stands for Transmission Control Protocol. Transmission Control Protocol, those packets which are called connection oriented. Connection oriented, and they are reliable. Like, what's going to happen if sender wants to send a data to, for example, this is sender and this is, for example, the destination. Sender want to send a packet to destination, they will make a connection first. Like, for example, if I want to send you a data, I will ask you, are you up, are you listening to me or not? If you respond me back, then only I will send you the data. It's a three-way handshake. So they establish a three-way handshake first, which is by using a SYN protocol. We will discuss this protocol in our chapter number 5, sorry, the TCP chapter, TCP/IP protocol. We will discuss the three-way handshake in detail. So TCP packets are connection oriented, reliable but slow. Like, for example, if you visit a website, you basically send a TCP packet. UDP is called user datagram protocol, and this user datagram protocol is basically unreliable, plus it is basically connectionless. So it's faster, by the way, but the counterpart is, the best thing is, it is faster than TCP. UDP is like broadcasting, for example. Let's say if anybody is listening to you or not, you will transmit. For example, ping packets, radio transmission, like you don't know whether people are listening to you or not. And ping packet, as you know, it can be successful, it can be, for example, fail, right? So there's no guarantee that if you send a ping packet to somebody, they will receive it. So UDP packets are basically connectionless. We have other, one is router static route. It's basically those information are associated with the router. For example, let's say we have a router where administrator set by administrator. So administrators, they basically set a route, a fixed route. And who set the route on the routers? Basically, in the router, we can have a fixed particular route where they will use the default gateway route, like how to get to the default gateway, or to the router. This route may be fixed, it cannot be updated. We can also let it like open-ended, which is router dynamic routing. What exactly it does, it basically updates. It gets updates, and what it does, it provides fault tolerance. So why we are discussing this is, mean, for example, we got a router. So as I told you guys, when somebody requests to the router, hey, I want to send this, this is my destination IP address. Router will see there might be plenty of routes, right? For example, let's say you want to get to downtown. To get to the downtown, for example, you can take, for example, 85, you can take 285, you can take, for example, GA 400, you can go from inside. So router will see where we have less route or shortest route based on the protocol and forward you the packet or your request to the destination packet. This is what the router does. So this particular route can be fixed, which is router static route set by administrator. Dynamic, it can get updated automatically based on the traffic congestion. There is another protocol called RIP, which stands for Router Information Protocol. Router Information Protocol. So Router Information Protocol, RIP, it basically uses the hop counts. So the hop counts are basically like how many routers are involved. Okay, we typically use trace RT command in order to find the hop counts. Then we have ARP. We're gonna talk about ARP in detail when we get to the TCP chapter. Address resolution protocol. And ARP, or address resolution protocol, what it does, it resolves IP addresses into MAC addresses. Uh, so this is all about the first agenda item. OSI model. We have discussed everything that you need to know about OSI model. Let's talk about DHCP and DNS protocol. DHCP and the full form is Dynamic Host Configuration Protocol. So DHCP protocol or Dynamic Host Configuration Protocol, it basically runs on application layer. Application layer, which is basically layer number 7. DHCP is basically a network protocol, so it means we use this protocol for network activities. I'm going to explain you how exactly it works, and it typically works on client server model. So for example, if you're using peer-to-peer networking, we cannot use the DHCP protocol. So in DHCP protocol, if you want to understand the basic idea about DHCP protocol. So in DHCP protocol, what happens? Let's say, for example, let's say I have a small local area network. I have, let's say, these 3 computers, and I want to connect them together in a local area network so they can communicate with each other. So let's say I have a central device, which is switch or hub. So these are connected with the Ethernet, for example, with this switch. Now, if I want them to communicate with each other, to design the local network, I need to assign them a certain IP address. So, of course, the switch or your local network will get a ISP, a static IP address from ISP. So, ISP will assign us a static IP address, which is our public IP address. We have already talked about it. And then we can do the private IP addressing in the local area network. So, I will assign them a local IP addresses. I can assign them a manual IP address. For example, let's say I can assign this 1.1.1. Let's say, for example, 1.1.1.0 was my IP address. This is my public IP address. For example, I have not implemented any NAT or PAT. So this IP address could be 1.1.1.2 and 1.1.1.3 is the IP address of this PC. No, it is very easy to do the manual IP addressing. Whenever any device want to get connected, I can, for example, manually assign them IP addresses. Second option is, let's say I have a large network. So if I have a large network having, for example, 500 computers, so it would be very difficult to do the manual IP addressing. It's going to be very, very difficult. So, and we can, of course, there can be some mistakes and some issues as well. An administrator will get a lot of work. So rather than doing the manual IP addressing, assigning manual IP addressing, we use a DHCP server, Dynamic Host Configuration Protocol. We can, and what it does, it basically automatically assigns the IP addresses. So automatically assigns IP addresses. So whenever it will have like this particular switch, we can integrate. Like, it's not mandatory that you have a DHCP server in the form of this computer. You can run the DHCP services on this server in this switch. So DHCP services can run in this particular switch, and it can automatically start assigning the IP addresses. You might have seen this particular thing when you are configuring your IP addresses. Like on your Windows machine, if you guys just check this button, if you just check the button, obtain a IP address. So this is basically automatically it will assign the IP addresses. It will use DHCP service. Other than that, I'll come to this point why this, if you check on this the automatic DNS server address. So what does it mean? We'll talk about it in a bit. But this is basically what DHCP does. It will automatically assign you the IP address. You don't have to do the manual IP addressing. Okay, so if you want to, so there are a couple of so the definition of DHCP protocol is going to be it assigns IP addresses, automatically for a least amount of time. I mean, you can define a time, like for example 2 hours IP addresses for that PC. So for a least amount of time created by or defined by a scope. For example, let's say I have 2 devices. Let's say this is my printer, and printer is going to be up for the whole time, because other computers, for example, this laptop and this computers and the cell phones, these can actually come and go. But this is, for example, my printer, which is going to be available 24/7, available 24/7. So how we can assign this sort of devices a dedicated IP address? So we need to basically reserve a static IP address for these sort of devices. Okay, so in DHCP, it does allow you to do reservation and exclusions for static IP addresses. So let me just give you a quick example of that. So for example, let's say this is my switch, and in this particular switch, I have a DHCP server running. DHCP service running. Let's say I have IP addresses 1.1.1.1, 1.1.1.2, 1.1.1.3, and 1.1.1.4, for example. I just have 4 IP addresses. So at a time, whenever somebody wants to get connected, let's say these computers are right now connected. So whenever they get connected, let's say this PC has 1.1.1.1, 1.1.1.3, 1.1.1.4. Now you may ask, where 1.1.2 gone? So let's say I have defined that this this is printer, and this 1.1.1.2 is reserved for that. It cannot be assigned to any computer. Now what's going to happen? Let's say this PC, this particular computer is gone. It is disconnected. Now my switch or DHCP server knows that 1.1.1 is free. Now, whenever somebody wants to get connected, let's say another laptop came in. So this particular laptop will get the IP addresses by the switch 1.1.1.1. Got it? So reserve IP address would be, I mean, we can exclude them from assigning or from the DHCP. Like DHCP will manage it, will not assign this IP address to any other computer. And whenever somebody leaves the network, disconnect with the network, the switch will reclaim the IP address. Okay. One very important thing here is, let's say, for example, I have a computer, let's say this PC, and this PC wants to get connected with DHCP server and doesn't get connected. So what will happen to this computer? In that case, there is basically a APIPA, as you remember the term, automatic private IP addressing. So for example, if a PC is unable to get connected to DHCP server. So for example, a PC is unable to get connected to DHCP server, then what's going to happen? It will automatically take an IP address from this subnet, so which is privately dedicated for the automatic assigning. So 192.255.254. These are basically the octet which are free. So it means the subnet mask is 255.255 network ID .0.0 can get any IP address from this particular range. So, but this is going to be only internal. Please remember, for outside communication, it needs to get a public IP address. One more thing about DHCP is basically DHCP. It's called DHCP relay agent. So what exactly it is? So for example, if a client is on different network, different subnet, so we need DHCP relay agent if client is on a different subnet. Right, so this is, by the way, what DHCP protocol is. We have talked about it. What is DHCP protocol is? Dynamic host configuration protocol. It automatically assigns the IP addresses to the computer whenever they need it for a specific amount of time, which you can define. If you don't configure the DHCP, we need to do the manual configuration. Manual configuration is good for small network, but not recommended for large one. Okay, for large network, we use DHCP protocol. We can have a dedicated server for DHCP, or we can actually install or run the DHCP services from the networking devices. So let's move on to the last topic, which is DNS, domain name service. And you guys have seen this DNS, the automatic DNS server addressing. What is DNS? As you know, DNS stands for domain name system, domain name system. That is what DNS is. And DNS, domain name service, or DNS, what exactly it does? It mainly resolves the FQDN, which is called fully qualified domain name, into IP addresses. Now we need to understand that why DNS is important and what exactly it is. So if you want to understand in simple language, let's say this is, for example, a DNS server. A DNS server, what exactly it does? If you, for example, give it a domain name like, for example, ggc.edu, google.com, or something like that, if you give a domain name as an input, it will return you with a IP address. So you'll get an IP address in return. That's what simply it does. But let's understand it, what exactly it do. Because we know that if you want to communicate with any device outside the local area network, if you want to communicate outside the local area network, we need to know the IP address. So without knowing the IP address, we cannot communicate over the internet. So over internet, we need to know the IP addresses. As you know, for local area network, we use the MAC addresses. Okay. But outside the local area network, we need to know the IP addresses. But the problem is that there are billions of websites, So do you think it is easy to remember the IP addresses of all these websites? No, it's impossible. So what typically we do, we use domain names. And in domain names, what exactly it does. So for example, let's say this is your PC. If you guys see, that's a simple model. So for example, this is your computer and you want to access, assume that google.com. You want to access google.com. If you want to access google.com, you will type google.com, and now this will go to your ISP. Your ISP has a DNS resolver. Okay. So firstly, google.com, this is your first request. You want to get to this website. You just type google.com. Okay. This particular information or this domain name will go to DNS resolver, which is held with your ISP. What DNS resolver is going to do? DNS resolver will see if it is a frequently accessed website, like a common website, frequently accessed site, then there would be no, it will not reach out to root name server, TLD server, or authoritative name server, which can be managed by ISP, but typically it is managed by IANA. Okay. Google has also their DNS server. Google has a public DNS server. You can also use that as well. Like for example, if you go down here, if you don't want to use the ISP's DNS resolver and server, you can actually put here a public DNS server address as well. So you can put the IP address of public DNS server. So in that way, here you can put the public, I mean, both can be filled with a public DNS server if you don't want to use the your ISPs. But it's always recommended to use automatic one because it will be filled with your ISP DNS server. Now what's going to happen if you type google.com, for example, if you are looking for a frequently accessed site, then DNS resolver will provide you with IP address. Provide IP address. They got a small database here. They will provide you the IP address. But we assuming that you want to visit a website which is not here in the DNS resolver. Then DNS resolver do further things. DNS resolver will forward this request to root name server. I'm going to explain you in a bit. Root name server will identify the top level domain. Okay. Let's say, for example, their top level domains are like you are visiting or you want to get to the google.com. So .com, .edu, these are called top level domain. Will forward that request to the concerned top level domain server. Okay. And again, all these can be managed by your ISP, as I told you guys, or there are independent bodies as well. Like this thing, DNS resolver should be with ISP, should have one. But these are optional. They can actually redirect you to public root name server, TLDs, and other. So what's going to happen? They will forward it to root name server. Root name server will find out the concerned TLD, forward to concerned TLD. Concerned TLD will forward it to concerned authoritative name server. Okay. I'm going to explain you in a bit, and then authoritative name server return back to TLD, and it will return back to root name server. Then it will return to DNS resolver of your ISP. ISP forward this IP address to you, and then you will be redirected to that computer. You can directly get to that PC or that server. Now, if you talk about what is inside the root name server. So in the root name server, It's just like, for example, mainly, so it's just like a tree. So this is the root name server. So root name server, again, you went your DNS resolve, you want to go to google.com, your DNS resolver doesn't have the address of google.com. So when this request will go to root name server has further top level domain, just like child. It will have, for example, .com, .edu, .mil, .org. I mean, there are many, as you know. These are called TLDs, top level domain. And each is TLD server, TLD server. So there are plenty of different TLD servers. Got it? Now, since you want to reach out to google.com, so this root will say, let me see, I don't have that information, but I have a child who knows the IP address of this domain. It will go to TLD .com. So .com will have authoritative server. This is authoritative server. Authoritative server. And this authoritative server have information about google.com and all that website. For example, google.com, maybe for example, GGC, maybe for example, Yahoo, etc., etc. Now this authoritative server, it got the DNS records. It has the DNS records, and I'm going to tell you in a bit. And it will find out the IP address. It has all the information like email server, all that stuff is basically in the DNS record. It will forward the IP address back to the top level, the root, and then root will forward back that information. Okay, this is basically how, like again, if you go back here, so top level domain has, this is for example .com TLD server, and it will go to the google.com. Google will forward back to the TLD root name, and then this route is going to be followed by the google.com, or let's say you will get the information about that. Now all the DNS records, so all the DNS records are basically held here in authoritative server. So you guys can see here for each particular web domain, it has the DNS servers, DNS records. And within the DNS records, there are plenty of information, like it has the host files. It has the MX. I'm going to tell you what is MX. It has CNAME. These are different entries in the DNS records. It has PTR. You just have to remember what exactly it does. It's important from exam point of view. Host names are basically host name files, or host files that typically it stores all DNS records. Here we have, if you see starting with A, the A is basically the host record. The host record IPv4, and it basically contains the domain name to IP address. So domain name to IP address, like it's something like that. So it is, for example, A, it will have the host name and the IP address. Let's say google.com, whatever the IP address is. If, for example, you have a host file with 4 A's, it means that particular host is IPv6. So it will have an IPv6 host record. MX is typically for email record, like email server address or email server address. CNAME is and PTR is basically reverse IP address to domain name. Okay. Now let me just wrap up the discussion. So what exactly the DNS server, what it does, it resolves the domain name. Like this is the main idea. You are providing its domain name and it will give you the IP address. How it basically gives you the IP address? So DNS server is basically this, like this whole thing is DNS server. This journey can be short if, for example, you're trying to access a common website, frequently accessed website. When this request will go to DNS resolver, if it would be a common website, you will get the IP address. If not, then DNS resolver will forward it to root name. Root name will identify with the top level domain. Top level domain will find out what sort of top level domain is and then get the IP address from concerned authoritative name server, which basically hold the DNS record, DNS records. And DNS record, it contains all that information which I was telling you about a specific domain, like host files, email details, their CNAMEs, PDR, and all that detail would be right there. Now, for example, if you have an IP address, something or the domain name, something like that, let's say mail dot, for example, abc dot, for example, org. For example, that's the address. So if you look at this IP address, a domain name, this mail, it basically tells you the computer or host name. Computer name, let's say this is dedicated for email server. It's basically the email server. Okay. ABC, that's basically the organization name. It basically specifies the domain name. While if you see org, which is organization, it tells the top level domain. That is TLD, top level domain. And again, top level domains, it tells the nature of the business. Domain name is the name of organization or the company, and it is basically the name of the server. That's basically how the domain name or information that domain names basically is telling us. So that's it about chapter number 7. If there would be any question.